Welcome, everyone. This is the recording of the December 2025 meeting of Princeton Chapter of ACM and IEEE Computer Society. We're talking about AI in the world of undergraduate computing education. Our speaker, Noah Cowit, is giving this presentation. He's from CRA. During this presentation, Noah asked us all to have small group discussions on several questions. Those discussions have been edited out of this recording, but the rest of the recording is very interesting, and we have some fun stuff to talk about on this topic. So, take it away, Noah.
At the University of Colorado Boulder to complete my PhD. I served as a visiting research scholar at the Hong Kong Polytechnic University, and next year I'll be joining the faculty at the University of New South Wales, Sydney in their computer science department. So who is the Computing Research Association, which is oftentimes just called CRA? The Computing Research Association represents nearly 300 North American institutions, computing research institutions. These are universities like this one, but also laboratories, centers, and companies engaged in computing research, including professional societies like the ACM and the IEEE, as well as AAAI. CRA was founded in 1972 and has a history of bringing together academia, industry, and government to support computing research. So the mission of CRA is to catalyze computing research through three methods: leading the community of computing researchers, informing policymakers and the public of the importance of computing research, and promoting the development of an innovative and responsible computing research workforce. This third bullet point is the one that NSF Level Up AI, the project that I'm speaking about today, most directly corresponds with. So what is NSF Level Up AI? It's one of many CRA initiatives that is dedicated to improving undergraduate AI education in the United States. The other two, the NAIR AI EDU Research Coordinating Network and NAIR Pilot Roundtables and Conferences, I'll be speaking about a little bit at the end of this talk, but now I'm going to talk about the center blocks in this diagram: the NSF Level Up AI Roundtables and the NSF Level Up AI workshops. So the NSF Level Up AI is an acronym that stands for Launching an Educational Vision to Expand Leadership, Understanding, and Progress in Artificial Intelligence. It's a community-led effort to expand capacity and access in undergraduate AI education, as I mentioned previously. We aim to build a shared vision for accessible, high-quality AI education, supporting educators and institutions in expanding their AI offerings, and leverage NAIR resources to enhance teaching and learning. The first part of NSF Level Up AI is the roundtables, which took place in spring 2025. The second part was the NSF Level Up AI Atlanta workshop, which took place just last weekend. And then the NSF Level Up AI Phoenix workshop will take place on January 7th and 8th, and these are both in-person workshops. So the roundtables were 32 moderated virtual discussions of 202 experts, mostly from institutions, mostly from academic institutions, across the United States. They were grouped by their type of institution, so R1s, R2s, community colleges, etc., to discuss the particular shared challenges and opportunities at their similar institutions. The Level Up AI Roundtable report has been published and discusses these first round of convenings and summarizes the practices, challenges, and strategies institutions are exploring, moving towards this nationwide community of best practices. However, this report was exploratory in nature. The questions we asked in the roundtables were not meant to solve concrete problems, but to see where the state of undergraduate AI education was and how we could go about charting a pathway towards improving it. The second part of Level Up AI is to try to more concretely solve the problems that were addressed in the roundtables. And so the Atlanta workshop, which took place last week, we had 90 experts flown out to Atlanta. And these experts engaged in 7 rotating charrette discussions about key challenges which were identified in the roundtables facing undergraduate AI education, and 7 backwards design workshops, which were also targeted to uh, address 7 key challenges in undergraduate AI education. Um, and this is the first group to hear a report out from the workshops or the one workshop because they happened last week. And I tried to incorporate as much as possible into this presentation for you today. So how should you understand this talk? Um, This talk is an overview of opportunities, challenges, and strategies for navigating computing education in the age of generative AI. But I'm not trying to imply that there's one right thing to do, nor one position that I or CRA highlight as ideal. But you can ask me about my opinions on this. But fundamentally, every undergraduate education institution and every undergraduate uh, computing teacher has their own uh, particular circumstances. And the purpose of this talk is to give you an idea of the landscape of different strategies so that you could use what works best for you, and not for me to tell you what you should or should not do. So the agenda here today is first we're going to talk about pedagogy. We're going to talk about challenges, opportunities, and strategies of how to do computing pedagogy in the generative AI era. Then we're going to talk about assessment. We're going to talk about challenges, opportunities, and strategies in the generative AI era. And then we're going to talk about other initiatives, and I'll give you a brief overview of other helpful resources which you could use. So first I'll talk about teaching, so pedagogy. Um, and the first question I want to ask is, what is the relationship between professional computer science and automated tools? And I'm going to draw a blunt and imperfect analogy that's sort of provocative and gets you to think. So 100 years ago, there was a job called a computer, and this was a person who was solving math problems all day. Now this job is done by calculators, and there's nobody whose job it is to sit down and solve multiplication and division problems all day. So what is the relationship between programmers and generative AI tools? Because we don't want to be training people to be calculators. We want to train them to use calculators and to complement the skill of calculators, with calculators being, in this case, generative AI. People still are mathematicians, but they need to do something a little bit different. So one of the roles of people in computing with generative AI is that AI tools are sometimes incorrect. What's produced is often unfinished and inaccessible to non-experts. This means that as of now, human editors and supervisors are necessary to modify and maintain AI outputs. So there's 2 key knowledge areas, which are sometimes in complementary, but sometimes at odds with each other. One of these is foundational mastery of computing topics. This is things like abstraction or data structures. The other is tool competency, which is most poignantly AI tools at the moment. And so we need to ask, how do AI tools help students learn, and how do they inhibit them from learning? And how can we help AI tools help students learn? So these are all questions to begin to think about as we start this conversation. So the first thing I'm going to ask you is to talk to a partner or a group of people. It doesn't have to be 2 people. It's an 8 a.m. talk. You could do whatever you want. 8 p.m. talk. So I'm going to ask you to talk. For people on Zoom, I'm going to have you talk amongst yourself. I'm just going to mute. What are the key challenges around teaching computing in the age of generative AI tools? I'm going to give you a few minutes to talk about that right now. Um, so as I was saying, I'm going to talk about some of the challenges that we've sourced from the computing research community and that we've compiled into resources to try to understand how to navigate this new situation. So first I'll start with talking about some student-focused challenges. So one of the big ones is that people are reporting that it's too easy for students to learn. What does that mean? Um, so if you use LLMs to code, you could have the LLM do stuff for you. And maybe you learn and maybe you don't, but what is bypassed is some of the productive struggle that's required for students to develop the deep mental models that are essential for building advanced understanding of computer science. Another issue is that even if students do the productive struggle in dealing with LLMs, they will need to use LLMs. And if they use LLMs without understanding them, relying on them as a black box, then they won't use them in a way that is effective. And so it's important to understand not only programming, but understand what the tool you're using does and what allowances it has and what it cannot do. There are also some faculty-focused challenges I'd like to talk about. So one of these is faculty comfort with generative AI. Although faculty are growing increasingly comfortable with generative AI, some faculty still are beginning to understand and to use generative AI themselves. And so it's difficult to teach that to students. Other faculty are having difficulty transitioning from a syntax-focused computing education to computing education that largely relegates syntax to AI tools and that tries to teach higher level design and higher level conceptual ideas first. So now I'm going to have you talk to partner for 2 more minutes. Instead of challenges, let's talk about key opportunities. What do you think having these generative AI tools allows us to do in computing education that wasn't available beforehand? So if you could get into the group you were in before and talk for a few minutes about that. Thank you. If people would like to share some of the stuff they've talked about, that would be welcome then, if we don't have to stop directly at 9. So would anybody either online or here want to share any challenges or opportunities in this case?
Critical thinking
Yeah.
is the thing that how can AI systems be used to improve students' critical thinking? I don't have a clear answer for how that to be done, but I think there's a need.
Yeah, critical thinking, definitely a huge thing. And the idea that AI could help with that is one that we've heard and that I'll talk about in a little bit. Anybody else with ideas? I'll also look at the chat in case people want their idea to be talked about.
Honestly trying to do the work themselves. If they don't have a way to get unstuck, then there's no learning taking place. So AI could say, this is where your problem is, and let them continue. And that's a wonderful use of the tool.
Yeah, so for people who might not have heard, the idea that students get stuck on a problem, and that can be a very discouraging experience, being stuck on a problem for hours at a time. And the idea that AI could get you unstuck from the problem and get you moving forward is definitely an opportunity that AI tools offer.
One of
So
the things we were discussing on the Zoom call is that you have more opportunities to read code as a student. And it's really tough for an instructor to generate a lot of stuff to give folks some examples of the practice.
yeah, reading and understanding and having those examples is definitely something that is important and is definitely an opportunity in computing education. So now I'll move on to some of the ideas that we've gathered through Level Up AI. And a lot of these are similar to the ideas that people have just shared. So I'll divide it the same way as I did the challenges into student-focused opportunities and faculty-focused opportunities. So the first opportunity I'm going to talk about is lower barriers to entry. This could mean a lot of things, but one of these things is that tangible things could be built quickly. Students no longer have to struggle for hours to get something that works and something that produces something. Although they probably won't understand fully what they build, the fact that they could build something could make them feel more confident and make CS more accessible and interesting to more diverse groups of students. So another possibility is chatbot tutors. So individualized tutoring and mentorship, breaking down problems and offering concept-specific assistance are all things which LLMs can do. And this individualized tutoring at scale for a lot of institutions would have otherwise been difficult to facilitate. And the final thing here, although this is not all of the opportunities, is the ability to do cooler, larger things. If we give LLMs, if we let students use LLMs to do 80% of the, I guess, grunt work and writing code, we can ask more of students, and we can ask them to make bigger, more interesting projects, more similar to what they will be having to do when they enter the workplace. So now I'll talk about some faculty-focused opportunities. One of these I heard just a second ago, which is focusing on concepts, focusing on key conceptual ideas rather than syntax specifics. I also read this on the online chat. Another one is curriculum reordering. What can we change about the computing curriculum now that we have these generative AI tools? Can we introduce applications and ideas before we introduce the mechanics of how to write code? And what are the positives and negatives of doing that? And then the third opportunity is introducing ethics into the curriculum. The prevalence of AI systems in everyday life has made questions of ethical, societal, and bias issues relevant to all students. And this will now be grounded in application and experience. And this is an opportunity for faculty to introduce these concepts into their teaching. So that is a summary of some of the key opportunities that generative AI offers in computing pedagogy. So now we're going to do one more of these pedagogy-focused talking sessions. So what are strategies? What are concrete ideas on how to use generative AI to improve computing education? So I'll give you a few minutes to talk about this right now. Yeah, so I'm inviting people to share with the group for people online who I did not unmute for. Yes, but yeah, one, Jan just shared that we can make the problems harder. We could make more complicated things for students to solve. Any other strategies that people spoke about?
Yes, because getting the syntax right, you've got to look up and then foliage. AI can just get it for you right away, much faster.
Yeah, so syntax is a key area where AIs could help students learn things, and we could use that strategically to assist in computing education.
I remember a wonderful film, Sorting Out Sorts, that illustrates just how bubble sort versus quick sort, and how having something which could just let it describe different approaches, different algorithms, and maybe animate them a little bit to grind things in what is going on with some different approaches to algorithms.
That's cool.
Yeah, so visualizing, making if I'm getting that right, like visualizing, making
Visualizing
interactive.
different algorithms and the advantages, the strengths and disadvantages.
Yeah, so helping and create teaching tools which help us show students how these things work. That's definitely a strategy which could be used to improve computing.
Yeah, Neil is basically suggesting involved in assignments like writing an operating system or writing a compiler, that you can have the LLM give early feedback.
Yeah, that's a very interesting strategy of how to incorporate LLMs into our pedagogy. So now I'll move on to some of the, I won't call them suggestions, but strategies. And if you see something you like here, feel free to use it. But this is not meant to be a prescriptive best practice. It's just something that we have identified in the computing research community. And so the first one is a scaffolded progression of when students are able to use AI tools. So this is one example of what a scaffolding projection could look like. In the first year, you could have AIs just be used as tutors, and students are taught how to use AIs, what AIs can do and what they cannot do well. And in sophomore and junior year, they could be used just for debugging and test cases. And then in senior year, they could be used as a full workflow tool. Students are able to use any of their capabilities to the extent that they're able to gain value from that. And this is just one example of a scaffolding progression of how students are able to use AI without AI inhibiting their learning and using AI to help their learning. The other idea, which I think Neil wrote about in chat or alluded to in chat, is using AI as a sort of agent in problem solving. So there's two ideas of what an AI problem solving assistant could do here. One of these is a traditional Socratic assistant, so using AI as a required teammate member that provides explanations and hints, but is instructed not to give the final answer. So you ask it a question, it responds with a question. And this is meant to promote reflexivity and thinking on part of students. The second example here is the bad agent. So designing an AI tool that's intentionally bad at a specific area. You ask it to not get the answer right. And this means that students will need to get the answer right themselves. They'll have to look at this and say, oh, this did not do this right. How can I change this to make it right? These are two different ideas of how AI agents could be prompted to assist students in learning. An example that's more faculty directed is faculty learning communities. So this is aimed to solve some of the challenges that we're all facing and making sure that we face them together. Faculty are able to co-develop AI-infused curriculum, creating environments, at least, where faculty are invited to co-develop these curriculum and share assignments and breaking down the siloed pedagogy that often is created between departments and even between professors in the same department so that we could learn from each other's shared experience. So that is the end of this pedagogy section of the talk. Now I'm going to pivot towards talking about assessment. And we're going to go through the same structure as we did in the first part. So first I'm going to start thinking about assessment in a very broad sense. So what are primary goals of assessment? We want to accurately measure learning. I think most people generally agree that that is a primary goal of assessment. Another important goal is fairness. We want to make sure that students are treated fairly. Grades matter to students and they matter to employers too. And so we want to make sure that a grade is earned. But there are also some other goals of assessment which now institutions are thinking about more. And they're thinking about, is a mode of assessment AI resilient or AI susceptible? For instance, auto-graders are going to be a pretty AI susceptible mode of assessment because they're very output focused. An AI could get the same response as a human, and an auto-grader won't ever be able to tell the difference of that. Another metric of that we're interested in, that people are interested in, that professors and AI educators and computer science educators are interested in, is whether a assessment method is resource intensive or more economical. For instance, interview grading, which is doing one-on-one interviews with every student who submits an assignment, is pretty AI resilient. It's hard for students to give a good explanation of what they did if they didn't actually do it. But having a TA or an instructor do these one-on-one interviews for every assignment submitted is incredibly resource intensive. And so the ideal is methods that are in this sort of yellow circle here that are both AI resilient and economical. So that is a large scale consideration as we move forward with assessment strategies. So now I'll invite you to talk to a partner about key challenges that I haven't spoken about just now around assessing computing in the age of generative AI tools. I'll invite you all now to bring the things that you've been talking about into the conversation, and if anybody would like to share at this time, please do.
we were discussing the standard problem of how do you know what work is the students? Right? You can't assess because they may have just copied it from the computer. Right? And so what do? You say, oh, we'll run a test, but the student will be in a tempest sealed room. So they can't use their cell phone to get the. Yeah.
My language, my language class.
Yeah.
I can look at the online and then I say put in envelope.
Yeah. Put your cell phones out in the open and then.
Programming or AI help. That's
Yeah.
Yeah, this how do we know what's the students and what's the AIs? This is very difficult when we're trying to assess students. Yeah. So I will move to some of the assessment challenges that we have identified. Some of these are probably very familiar to your conversations. We don't have traditional take-home programming assignments are no longer a reliable indicator of what students have learned. And this is a huge problem. To some degree, it sounds like there's a fear that there is no assessment method that is a reliable indicator of what students have learned. The assessment methods that are most AI resilient tend to be hard and expensive to scale, like conducting live interviews where students don't have any AI access. These also have the risk of disadvantaging introverts or language learners or neurodiverse students, students who might not sign up for computing courses to be in a public speaking role. And the final challenge is that if we aim to try to prevent students from using AI, we could engage in an intrusive and expensive cat and mouse game where we're trying to police the use of AI in increasingly more significant ways, but which we're always able to be outfoxed by students who are just going to find a different way of using the AI. And I saw a lot of conversations like this online or on the chat. So now I'm going to pivot to a more optimistic question. Are there opportunities where we could use AI tools to make computing assessment better? So I'll invite you to talk again about this. So there's a lot of very interesting conversations going on, especially online. So I'd like to invite those to be shared with the group. So would anybody like to share?
One of the things we're seeing on the chat is the issue of, ugh, we're really struggling to do this, but it's like, even if we could do things like, as an instructor, we could say, let's look for common failure modes from students' work and say, oh, that's what we have to teach more about. But it's not really getting to the problem of we can't really decide if this is a fair assessment of what people are doing. Right.
So it sounds like there are thoughts of how AI tools could be used to teach computing, but that there's still that question of fairness, which is thorny and difficult to answer. So what other thoughts have people had?
And this was one that was good. One key opportunity is to assess students on their ability to work with AI as a collaborator, not just as a tool. As AI becomes more integrated into industry, evaluating skills such as prompt engineering, critical analysis of AI outputs, and effective human AI teamwork will be essential.
Yeah, so that's
But that's you're kind of now at the meta level, and you bypass the whole thing of, are they going to get any basic skills here anywhere in the near future?
yeah, and that's another key concern, if we just give students AIs and say go wild, we face that earlier issue of AI inhibiting students learning these key ideas.
And there's no organized presentation anymore of the basics.
Or how could we make an organized presentation of the basics today?
Integral into the teaching strategy. Yep.
Yeah.
Yeah, that's a good point.
Yeah. So I know it's 9:02, so we'll try to go a bit quicker now. But now I'll talk about some opportunities that we found, and then we'll get to the final break off, which is about strategy. So the first opportunity is we have the opportunity to evaluate higher order skills. We could ask students to do things that test them on whether they understand the material versus just make code that works. So this is one opportunity we have. We also have the opportunity of workplace alignment. So we could assess code auditing and process. We could have students do things that they'll be asked to do in the workplace. The workplace isn't going to care as much about what students have learned. We care about what students have learned, but we have the opportunity to ask students workplace-oriented questions, and that is one of the opportunities that we have. It doesn't negate the necessity that students learn the foundations, but it is an opportunity that has been brought up. And then thoughtful design. So we could do something more interesting than auto graders. We could give students assessments that they're more excited to answer, and questions that are richer and which aim to capture their thought processes. So those are 3 assessment opportunities that we noted. So now the final break-off. I know that everybody's getting tired, but if you could give this one question, which is what are the key strategies to assess computing? 2 minutes, and then we'll come back and talk about that. So now I'll start talking about some of the AI and assessment strategies that we've identified. And I've divided these into 2 main groupings. So the first grouping is about controlling the use of AI in assessment. And the first one of these is the tempest-sealed room, as people were phrasing it. These are secure, controlled environments for student evaluation without access to AI tools. If you need to, take student cell phones away, have rows of computers that are not attached to the internet, and have students do coding tests in this room. This is probably the best way of preventing students from using tools that we don't want them to use. There might be ways around it, but it's probably the best way of doing this. I'm just checking to make sure. Yeah, I'm not muted. Just wanted to check to make sure of that. The second strategy here that is about controlling AI in assessments is requiring student explanations. This could be interview grading, short interview grading. It could also be a video submission where students explain their code to verify authorship and understanding. In all of these, we often face the trade-off between how expensive is this to implement and how effective it is at catching students who are not doing the work that they're saying is their own. And the third of these is requiring student documentation. So students could submit prompt logs and version history to demonstrate the process and effort applied to a problem. This is how many times I've pushed to my GitHub. This is all the time I've spent on doing this. And this could be faked, obviously, but it's another verification method which is aimed at controlling the use of AI and making sure that students do the work they claim as their own. So the next 3 assessment strategies are using AI and integrating that into assessment. One of these is having AI write the code, and then students have to assess the AI code. They have to comment on that. They show what went wrong, how efficient is this, how inefficient is this, asking students questions about AI-generated code. or even asking students to generate AI code themselves and then explain what that AI code did with their own comments. They could also ask the AI to explain what the code did, so it's not. But these are not strategies designed to control AI. These are more AI integrated assessment strategies. Another strategy is having the students attempt a problem and then use AI to solve the problem. And students might not successfully solve the problem, but they have to try. And then they would compare their own attempt and the AI output and give a critical comparative deconstruction of these two outputs. And this would hopefully help them learn. Another final AI integrated assessment strategies is just giving students AI and saying, go wild. You could use AI as much as possible. We're just focusing on the output. And this is the more vocationally oriented approach. These are all different strategies which have been fielded and which all have different potential use cases. So other strategies are more about expressing clarity and fairness to students who are also dealing with generative AI and their classmates using it, and trying to understand what they are and are not allowed to do, because this is going to be change for them between classes, between institutions. One important thing is specifying to students what AI use is and is not allowed, and clearly specifying this, so that students don't feel as though they are cheating or are worried that they're going to be cheating. Another thing is focusing on addressing some of the root cause. So student struggle and pressure, particularly in programs with a lot of struggle and pressure, might be the reason students use AI, more so that they don't want to learn the material. They're paying a lot of money to learn the material. They're chose to do this because they want to learn the material ideally. And then a final strategy here is offering pre-recorded oral exams in some cases, particularly for the interview grading stuff that people have been speaking about, to help students who have less confidence in speaking live. So that's the end of the main body of this talk. Now I'm just going to briefly share with you some other AI and CS Ed initiatives. So the first one is an initiative that's associated with CRA called the Gen AI and CS Education Consortium. This is a Google-sponsored initiative which is dedicated to empowering post-secondary educators to strategically integrate generative AI tools into their courses. It provides resources, training, and model curricula that focus on developing advanced and industry-relevant skills while maintaining the same academic rigor that departments need to teach effectively. And I could give you a moment if you want to scan the QR code or type down the link before moving to the next slide. And I could also share this slide deck afterwards if you would like. So the next resource is a book called Learn AI-Assisted Python Programming with GitHub Copilot and ChatGPT. This is written by Leo Porter and Daniel Zingaro. Leo Porter is going to be our keynote speaker, CRA's keynote speaker at the Phoenix Level Up AI workshop in January. And so this is a very popular beginner-friendly guide that teaches the essentials of Python programming while showing how to leverage AI tools like GitHub Copilot and ChatGPT. Another resource is CS Splice, which is less focused on generative AI in specific and more interested in building infrastructure and sharing infrastructure with the entire computing education research community, so that we don't have to solve this problem on our own, so that we have a resource repository of strategies which we could use. And now I'll talk about the NAIR pilot classroom and expansion conferences. So NAIR is an initiative, an NSF initiative, which aims to provide high-performance computing resources to institutions that don't have access to those necessarily, don't have the money to fund producing that themselves. And so the NAIR pilot expansion conferences are designed to introduce institutions across the country of how they should access these resources if they want to use them themselves. And these will take place in the form of roundtable discussions and in-person workshops that are focused on different institutional types. And you could sign up for these potentially yourself if you would like to attend one of these and you are a member of one of these institutional types. The NAIR pilot classroom will also have an AI EDU hub with resources for AI education at the undergraduate and master's levels, and fellows, which are 15 people who are paid a stipend to effectively distribute NAIR resources across the country. So if you want to get involved in the NAIR Classroom Expansion Conferences, which are going to be happening next year, feel free to scan this. I could also share the slides at the end of the talk, so you have access to this. And so finally, I'll just say thank you. Ran a bit late, but it seems that that wasn't a huge concern. Yeah, if you have any questions, please let me know.
Questions? I know I have at least 15 questions.
I'm here. If you want to ask 15 questions.
I actually saw a webinar that was given by the two guys who did the Python book. Because this was like a book and a course for CS 101, beginning programming with Python, right? And their idea wasn't, we're not here to teach you AI. We're here to teach you introductory programming with AI. So the first few steps are, make sure that you can get, signed into ChatGPT, and these are some of the things you can use. Yeah, here's some of the tools that you can Copilot. It's like, oh, okay. And then, but they do have a series of topics that make you think about real, programming concepts as opposed to coding concepts. So that's a good thing. I'm just wondering how that works at the intermediate level, right? When you start getting into data structures, when you start getting into real time, when you start getting into, all the different complexities of like database, database consistency and things like that, is there going to be a path that is kind of AI guided, third normal form to, or something like that?
I don't have an answer to your question,
Yeah.
unfortunately, but it's a great question.
Yay.
Yeah, I mean, these are the balance. I guess in this case, we're dealing with a lot of best answer, I would say, is that it goes back to what we want to prioritize, the use of students' ability to use these important tools, or they're learning foundational concepts, and how can we prioritize both?
Let me ask another question then, and that is some of these resources for education and some of the higher level concepts and stuff like that, where will some of these materials and some of these ideas and concepts come from? Are they going to come from initiatives that are put together by the big industrial companies in the AI business, or is it going to come from the grassroots?
And what is the grassroots in this?
The grassroots, the real grassroots are the students, right?
Yeah.
They're the ones who, have the mental flexibility to say, oh, yeah, I can explain this to somebody else this way, and I show them an AI example or something, something goofy like that, right? And it doesn't necessarily have to be very expensive, but it's, it's like the little steps.
Yeah. How much should we develop our education to fit the stated needs of industry? How much should we listen to students tell us what they need to know? And how much should we lead ourselves? These are all important questions, I think.
All right. I'd love to have a tutorial on how to run a code review or a code inspection, because I had to teach this in my company and it's not easy. Because people hate to read their own code. And then once it's somebody else's code, it's like, I don't even want to bother, right? I don't understand this. I don't get this. I don't know. Why are you asking me to do this?
But if you know someone's going to be reading your code, you tend to code better.
Yeah,
That's one of the things that comes out of code review.
yeah, yeah, yeah. And you become more self-critical, right? It's like, oh, yeah, I can catch this stuff before I get nailed to the wall.
Yeah.
Oh.
Something like Dennis's area, refactoring.
Oh, refactor.
Okay, imagine that you had a database of programs that were started and then refactored, and you train an AI system on that. And now you give it your code and say, can you help me with refactoring this program? It's gotten too complicated.
Yeah, that's, I think, one potential use for AI to help us uh, navigate computer science questions and help us potentially then, if it's an effective strategy, teach that effective strategy as well.
Yeah, old code, legacy code is one of my favorite topics. And of course, in the age of AI, you just throw it away and ask AI to write a new one. And then you say, where did my buttons go? Why are all my menus changed? And it's the Microsoft Word problem, version problem, like
Can you
over and
update
over
all my
again.
COBOL code?
Oh my God. Yeah, we had a guy here that was involved and had tools for helping to translate programs from one language to another. You remember? Yeah. Steve Hefner. Yeah.
Yeah.
Moved out to Arizona and
He's kind of an international background. I wondered if you see differences between the way we're doing things here and Europe and China, the rest of Asia.
I thank you. I hope that's I'm not sure I would consider myself as having an international background. I did spend almost all of my career here, but I did spend 5 months in Hong Kong, as you mentioned. When I was there, unfortunately, I didn't get a great understanding of how teaching was done because I wasn't teaching there. I was a researcher there. But so I don't feel super confident at answering the question, but thank you for asking. I think that's an important question. Yeah.
But it seems like it's something that we need to pay attention to. Like, how is this question being attacked in, China might be completely different. It might be better or worse than what we do.
Absolutely. And I know a little bit about how the institution that I'm going to be a part of is dealing with that. And from my conversations, at least several months ago, it's that they haven't really changed their curriculum much at all. They've been slow to move to change their curriculum. And that's just one institution in Australia. But I imagine that different institutions are moving at different paces to adjust or not adjust to changes that we're seeing in how students are learning and people are teaching. Yeah.
The previous slide had that bad agent, but you also had the Aristotelian agent. Do you know of anybody who's implemented those kind of things where, that's the thing you would be most worried about when somebody goes to a tutor? Are the tutor going to teach them, or are they going to give them the answer? Because the easiest is to give them the answer. But if you could get an agent to ask questions to lead them to the right answer, has that been implemented?
Yeah, so I haven't implemented this myself, but I've spoken to people who have. And for the people who have implemented it, they've seen some success in implementing it. There's no way of preventing students from just asking a non-Socratic agent the answer to the question. But the idea of this is that, that students have some intrinsic motivation to learn, that that if you provide them a helpful learning resource, they'll interact with this helpful learning resource, that they'll ask it questions and they'll ask some questions back. And that this is not a way of preventing students from cheating, but it is something which can help students learn. And so that's I think what I've gathered from this tactic.
All right. I think we're done.
Thank you.
Yay.
Yeah, thank you all.